point that you talked about
Yeah,
JavaScript.
sure.
Uh, the thing is, like, as in my case, or we being new, like trying to do two, three things together, like trying to learn Python together, then JavaScript together, and sometimes we get lost too much details, like how they say Java is object-oriented programming language, and then Python also has its class and object-based programming,
Yep.
syntax. While you try to do both, maybe it's beginning. That's where we get confused. So, what would you advise? Like, spend a lot of time on it, getting that fundamentals clear, or like kind of just dive into it, go ahead. Yeah,
So, well, I would dive into it. So you mentioned like object-oriented programming.
correct. Yeah,
I'm a big fan of object-oriented programming. I think it's a
yeah.
very good way to view software systems.
Okay.
As it turns out, when you get into these web infrastructure, web architecture sorts of things, you don't tend to actually code in object-oriented ways. We architect is still in object and systems ways, but we don't actually code in them. Sometimes, like it's object-oriented programming becomes a tool that you use when it's convenient, as opposed to something like we used to do back when object-oriented was like the thing that everyone wanted everyone to do, right? Especially like with
Mm-hmm.
Java and C++ with templating.
Right.
Um, it was everything should be a class, everything should be an object, and we've moved away from that. And the reason is because of the boilerplate and the verbosity that you tend to get bogged down in when you're making these systems. While it's a very uh, while object-oriented programming is a very good way of doing doing things in the sense of let me put someone in a breakout room real quick. I'm going to assign Shwetha and Justin Cartwright to breakout room 2. Yep. All right. So, so while object-oriented programming is a very powerful way to think about something, it's not always the most powerful way to code something. And the reason is because you tend to, as long as you keep thinking in the context of object-oriented programming, if you actually code in object-oriented programming, you would end up writing so much boilerplate code and
Mm-hmm.
get lost in the abstraction of it
Right.
that you end up never actually completing what you want to do. And I
I
can't
see.
tell you the number of times I have gone down that path.
Okay.
As engineers, we tend to like abstract things and want to do things and make everything fit in its own little place and everything. And
Mm-hmm.
you end up doing that with object-oriented programming, and you never actually get done what you needed to get done.
Right.
And I think the big knock on Java as a language, specifically, at least in my opinion, and you hear a lot of this from other people who are not Java supporters. Not that I'm not a Java supporter. I think it's a fine language. I think it had its time. The thing with Java, it's so verbose because
Mm-hmm.
every single thing has to be a class. So you can imagine if you just wanted to script a little, simple thing to process some data, why does it have to be a class, right? Like, why do I have to come up with a massive like object-oriented architecture just to process some data? Because you end up making a POJO, right? An object to handle like all of your different, data structures. And then you're like, well, it would be really nice because I have voltage here and current here. I'm actually going to make a class that I'm going to make a sensor class, and then inside that sensor class, I'm going to make a data type class, and then inside that data type class, I'm going to make an interface for that, and then you end up like making all this stuff, and it becomes so beautiful architecturally, but you never actually ended up doing anything. You just wrote a bunch of boilerplate code all the way through, to make it good. So
Everything. Yeah.
um, I tend to like JavaScript, Python, and some of these more scripting languages,
Mm-hmm.
especially Python, because in that regard, because you do have the power of defining objects and classes, which I'll do sometimes,
Mm-hmm.
but only when it makes sense to do that. Usually, if I'm making like a connector library or I'm making some sort of interface to maybe another software development kit or an API. If I'm trying to, connect to an application programming interface or something, I might make a class around it and then make methods associated with it, right?
Right.
But most of the time, when we're coding these really massive systems, we don't. Surprisingly, we just don't code in object-oriented ways because it tends to, slow you down in a big way. So here's my advice: don't worry so much about that object-oriented programming. I think you guys, as very experienced engineers, you already think about systems. You always think about things in a systems and object-oriented way. I mean, we do as engineers. We have to. That you already kind of bring that intuition to your code. So you don't really need to worry about forcing some strategy or some I don't know, some strategy to force you to think that way. Whereas a computer scientist, it was actually used as a teaching tool, and that teaching tool was a really interesting way to try to get software or computer scientists, really software developers who are not engineers, to think in systems oriented ways, so that they structure their thing correctly, and you get big teams that are all working together and define your contract and insurance clauses and all that kind of stuff that goes with contract programming, to force a team who is not a system oriented thinking team to do that. But if you're already a system oriented thinking team, you don't need all of that boilerplate, all of that added bloat to get that. And so my advice is, don't worry so much about trying to force it in an object-oriented way. You're already going to be thinking that way intuitively. So just think about the problem and how you would solve that problem.
Yep.
Not put a bunch of code together and all that kind of stuff. So yeah, don't get bogged down in that stuff. You'll waste a lot of time. It's fun, and you'll come out and be like, man, I feel really good about that architecture. I wish I would have solved the problem that I actually set out to do. I'm going to open up a oops. All right, so JavaScript. I'm going to create. I just have a window open here. I'm just going to create an index.js. If you remember, I said that the reason all our JavaScript files, the main files, are called index is because it's by convention. The other thing is JavaScript typically, by nature, and this actually comes from the web, will use an index as the main entry point, and so it just assumes that file. So it always looks for an index.js file and will run that if you don't specify an actual file when you run it. So if we start looking at this kind of thing as from a JavaScript perspective, can anyone think of a problem that you'd want to solve or something? I mean, give me a challenge. Like, what's a typical programming problem that you'd run into that we can look at solving with Node here?
Well, like a shopping list or something like that you could remotely update, or
Could do that, like a shopping list.
Or like a task list kind of thing.
Yeah, we could do a task list.
Or a bomb.
Trying to think, because I don't want to build a bunch of web stuff around it. I actually just want to focus on the language, so I don't really want to. I don't want to create a whole
Your
thing.
server and all that. Yeah. Okay.
Yeah, because we'd spend more time on the communications than we would on the language. Because that's why it may seem like, man, you're having us learn Python, you're having us learn JavaScript all at the same time. So it turns out it's all pattern stuff, right? The languages actually end up looking relatively the same. The details are different, but you end up doing the same things in all the languages. And so it may seem like a lot at first, but you realize that you end up not dealing so much with some of the more critical things in the language until you actually absolutely have to. And so I kind of want to explore JavaScript here to kind of bring out some of the more interesting things that that can happen with, particularly talking about async await. Let's do an async await example. Let's do why don't we like fetch a web page and kind of do that. So what I'm going to do here is I'm going to do an npm init. So this I'm just going to create my node project. I'm going to npm install or yarn install node fetch. Node fetch is like requests in Python. It's just a client, an HTTP client. And so I'm going to fetch equals require node fetch. And so I'm going to all right, so in Python, if you remember, if we do a if we do this analogous kind of thing here, right, where this is Python over here and this is JavaScript, I can say import requests, but I actually would have to create a virtual environment. So JavaScript over here, Python over here. And I need to pip install request. So I've imported requests here, and I'm going to say res is equal to requests.get, and let's just say google.com again. Someone's got a better website that they can. Let's do I'm trying to remember. There's a yeah, there it is. There's a fake online. There it is. There's a fake online REST server. And so this is, we're just going to hit this URL. So you got JSON placeholder type of code /todos/1, right? That like this todos is to your point, Justin, about, you know, a task list or something. And then this 1 is just a resource number. So from a RESTful API standpoint, we basically have the URL, right? If you look at our network, you go back to our networking prep video, we have a resource of to-dos. That could be like our vehicle, right? Remember from our class. And then this 1 is just the ID of that resource. And we can say print res.json because we know that what's coming back is JSON. So let me do, so python main.py. And you'll notice that it came back like that. I'm going to do something here. I'm going to say import DevTools. I'm going to say from DevTools import debug, and I'm going to say as print. You might say, what just happened there? Well, I'm going to install DevTools, just a library from pip, just like requests is. And it gives us this debug, which prints out things very nicely for us for Python. Literally just a debug statement. It's a print statement. And I'm calling it print. And the reason I'm calling it print is I could use debug down here, but I'm just saying, well, I prefer to just use print because I'm so used to typing print because I typically type it. And it's going to do the same function as print. I can also always pull that out at any point, just comment it out, and print will still work. It'll just do what the common behavior is. So it's kind of allowing us to go back and forth. So you'll notice that if I do this and I run main, it now printed out a really nice, pretty JSON, right, or dictionary for Python. As before, if I were to just go like this and run that, well, it just gives me a nasty one-liner. Gives me that text. So that's all I'm doing. I'm just making it a little bit easier to read. No magic there. All right, so we've got a user ID, we got an ID, title, whatever the fake Latin is, and then you got the completed false, right? So that's what a get does on this specific resource. I randomly just pulled this online. I don't know what these mean. We don't care what these mean. It's just something. It's just an API, application programming interface, we can get information from. It's like our vehicle stuff, right? So let me code the exact same thing in JavaScript over here. So I got node fetch. Node fetch is just requests. It's the analog to requests in JavaScript. And there's a number of others. Like we used Super Agent with Mocha last week. If you remember our testing framework, you could use Super Agent. I like fetch because it's API compatible with the browser-based fetch. And you'll learn all about that next week or on Thursday with JC. So when we do front end. But for now, I'm going to use fetch. And to make this really, really obvious, instead of saying fetch, I'll call it requests. So it's close to the same thing in JavaScript. And so I'm going to say let res equals. Now you notice some changes, some differences here already, right? We've got require as opposed to import. That's just JavaScript, right? It's still pulling off a folder in node modules of lib and then node fetch here, right? And just like in our venv, which is our Python, we're just pulling off requests, which is somewhere in here. I don't even know where it is. It's somewhere in that folder. But we just installed a couple folders and we're just collecting dependencies. So same type of thing, node modules and venv, right? So I'm going to say let res, defining this variable res. You don't actually have to define do any keywords in front. I'm going to say requests dot I think the API is not dot get. Instead, it is just requests, and I'm going to do that. And instead of doing print, I'll do console.log. Once again, a node thing, node JavaScript thing, and I'll print out res. Now, what any of you JavaScript guys are learning? Arif, you've been doing some JavaScript learning, right? What do you think res is going to print out there?
It's in the website, like nice.
It's actually probably going to print out a promise. And this is where the two languages diverge very quickly. So let's try it. Node and index. And you'll notice it prints out a promise pending. Oh man. Whereas this was real easy, right? You got your lines, did the work, you're able to convert it right there. But this, we haven't even gotten to getting the JSON out of it. It's already stopped us at this promise pending. Now, what the hell is a promise? Well, this is where asynchronicity in a language comes into play. So what it's actually doing is this call requests is returning what we call a future. Actually, what it's turning is a promise, which turns into a future. And what it's saying is, what JavaScript is telling me, or doing here, is that, hey, I'll run this for you, but I won't be done yet with running it, because it may take me some time to get that response back from the server, but I'm not going to hold you up. I'm going to let you go on and keep executing this code like console.log res, and then I'll give you a promise. And then I'll fulfill that promise as a future whenever it comes back to me. And then you can handle it however you want. Now you might say, whoa, okay, that's interesting, but how the hell am I ever going to use that, right? Do I use it later down here? What if, do I do something down here with it because it's as a promise? When do I know when it actually gets fulfilled, right? Well, there's an API, this promise API is, now we're starting to talk about objects and stuff. So your question on object-oriented programming is very interesting, because what this is actually a promise as an object. And as a class, the promise object has a method, and it's called then. And so what we can say is, this is where functional aspects come into play. We can say requests dot then. Now, I'm not going to do that. I'm going to say, okay, well, let me do this. I'll say res dot then. So what I'm saying here is that I know this is a promise, and so when a promise is fulfilled, so when that promise is completed, is kept, then I'm going to do something. And so there's this method called then, which I can provide another function to run when it's done. So it's a callback. So I'm going to then define another function in here, like that, and then I'm going to call this data. So the data is actually what I want back from this thing. And so I'm going to then console.log the data. So let's run that. Oh, that's cool. So what is all that? Well, as it turns out, if you notice, this is where I started running this file, right? So it first printed out promise pending, which is what we'd expect, right? Because it's actually this line. So line 9. And then we'll print out inside then, or I'll just say promise fulfilled. And so let me run that again. So I'm looking for line 9 here, and then promise fulfilled. But that's strange, right, from an order perspective, because what we've got here is this line is after here. And in every programming language we have ever used, right, MATLAB, Fortran, Prolog, just go back, whatever, C++, Python especially, like, you would never see a line run after first before another line before it, right? Like, that's like totally non-intuitive. Well, that's actually what's happening here, because what we're saying is return a promise and then execute this function that we defined as soon as you're done fetching this HTTP response. And we know for a fact that it takes probably on the order of 500 to 600 milliseconds for this response to come back. So while this over here in Python land, this took 500 or 600 milliseconds to complete, Python actually blocked the execution of this for 500 or 600 milliseconds. That stuff adds up, right? Whereas over here, it said, I'm not going to block. I'm just going to keep going, and then I'm going to execute this once my statement here, my URL, returned. That's a pretty powerful thing if you think about it. And so what we have is that this data comes back, this whole thing here, which is just the fetch object. And so I am going to actually do a .json here, which is very similar to this, and convert whatever the response is to this URL into JSON, and I'll just print that out with it. So let's see what happens there. Oh man, another promise. Now that other promise is cool, because now what we can say is, geez, now I'm going to move this out here. I'm going to say let the response equal to JSON, and then I'll print out JSON here, or I'll print out the response, which is a promise. But then we can say, all right, response dot then. We'll just do another function. We'll call it JSON data. And now we can console.log the JSON data. So we have these nested promises. It's really awful stuff. There it is. Finally, we got it. But we had to fulfill 2 promises before we got there, because it turns out that Node or JavaScript, it knows that it may take some time to deserialize this JSON. When I say deserialize, it means get that byte stream that's coming back from the cloud, right, that holds this line. And then what it does is it will then convert that to JSON. Well, that might be a very intensive process. So it says, I'm not going to hold you up while I do this. I'll let you continue. Just let me know what you want me to run when I'm done with this. And that's what this then is. So it's a pretty nasty statement, right? I mean, there's lots of stuff. Well, we can make this a little better. So let me comment this out. And let me erase some of these console logs here. Now what we can do is we can actually chain promises together. So we can say then data, and then instead of doing this response.data, I'm just going to say .then, and then pass this function in here. So we've made it a little bit cleaner, right? And in fact, if we wanted to, oops, I'm going to move this down here, and I'm going to chain that to the end of that. So all I'm doing is I'm just chaining promise then functions on, because they're just returning, right? This thing returns a promise, so therefore I should just be able to do .then as opposed to assign it to a variable. There's no magic that's happening there. I'm just shortcutting the variable definition, right? Don't need to worry about that. And then on data there, and we're good there. So this is still pretty nasty, right? So what can we do? Well, we can take that and we can do this, where we actually will return. So if this is that, we can return a promise, and then chain that down here to where it's now JSON data. Because we now have 2 chained promises. They're all equivalent, because we can do .then, and then we're just returning another promise into this, and then we'll do that. So there we go. So we got that. Now that's pretty nasty too, because I mean, what happens if you have things that also depend on this? Basically, your code is just a bunch of then statements, right? And they just keep nested down, down, down. It's actually something that's called callback hell. It's a very well talked about. There it is, callbackhell.com. And you'll notice that you have all of these. You just keep going down and down and down, and it's just like this creates this pyramid shape of just promise after promise after promise. It's just so awful. Like this, let me actually, sorry. It just keeps going deeper, deeper, and deeper. It's just so nasty. And then you have all these callbacks and everything. And so it's like, keep your code shallow. It's actually what I just showed you there. Oh, here's a Here's a request here. Stuff like that. It's just awful. So there's a lot of techniques to deal with it and all this kind of stuff. Frankly, I hate this, right? I mean, this is just awful. It makes no sense, and particularly when you're trying to like just think linearly, right? I just want to get a problem done. Like, why do I have to think about like all this nested callback shit? So there is another way that was introduced probably in 2 years ago in ES6. Now we didn't. If you watch the prep videos, we went over like ES 2015 and ES 6 and 7 and like how the evolution of JavaScript happened. We won't go over that right now. But they introduced a concept called async await. And it's actually part of the syntax now. And that's actually what we use most of the time. And so what we can do here is, so this is equivalent now. What I'm going to do is I'm going to say await, let res equals that, await that, and I'm going to say console.log await res.json. And if I run that, oh, that's not going to work. I'll tell you why here in a second. And it's another function thing. But this makes it look really similar to Python, right? These two lines are equivalent to this. The only difference is that we now have this keyword await in front of it. And it's what we're doing, right? We're awaiting a promise. And so we're saying, look, block this line. I want you to finish. I want this line to finish before executing anything else after it. So we don't have to like worry about all those then statements and all those promises and all that kind of stuff. It's just a really nice way of doing that while maintaining the power of the asynchronous nature, because there are a lot of cases, particularly when you're doing like web programming and things where you need to like do a lot of things concurrently, and communications programming and stuff, where you don't want to wait for this. And so it's like, I don't really care. I'm going to start it early and let it go, and I don't have to spawn a new thread and do all that kind of stuff. Just let me know when it comes back, and I'll take care of it then. So you can do a bunch of different things all at the same time. That's a very powerful thing. We'll do that next. But I'll show you. Why didn't this work? Well, it says await is only valid in an async function. And as it turns out, you actually need to create what we call an asynchronous function. And so what we have to do is we have to say function. Well, I'll just call it main for now. And I'll put this inside of main function. But I need to make this function async. So I need to say this is going to be an asynchronous function in order to use that await keyword. And then to run it, I'll just call the function. So I define it, and then I call it right here. And there we go. So we went through all this crap up here, a number of different ways to get it, and we finally made it right here. Pretty close to equivalent to this. In fact, it's very equivalent. You know, the only difference is we wrapped it in a function because we had to in order to use it at the top level in Node. That's it. Most of the time you're defining functions anyways, right? So it'll look pretty much the same. In fact, I'll do the same thing here. Def main. There we go. Those are exactly equivalent now. Even close in syntax. Python, JavaScript. So that's pretty cool. So now, most of the time you'll use this await thing. Now, what are some of the cases where you might want to actually take advantage of this asynchronous thing, right? Well, a lot of times what you have is where we want to actually do a number of different calls at the same time. So let's do something async. asynchronous. If I can spell asynchronous. How do you frickin' spell asynchronous? That looks about right. Asynchronous. Yeah, that looks about right. Okay, so let's say we have to do a bunch of calls all at the same time. So let's say we have to do let's do lots of stuff. Let's call this function lots of stuff. We'll make it an async function. And we'll say, all right, let's say we have to get 5 of these things. So what we're saying is I need to get a to-dos of ID 1, a to-do of ID 2, 3, 4, and 5. None of them depend on each other, but I need to get all of them, right? All at the same time because I need to operate on them. So what does this code say? Well, what this says is that I have to wait for this to get done. Once I wait for that to get done, then I have to wait. I'm going to start and call this one, then I have to wait for that to get done. Then I have to wait for this to get done. Then I have to wait for that, and then finally, after the 5 of them, I'm done. Wouldn't it be good if I could actually fire off the requests to all of it, let the server handle all those requests, and then get back to me as fast as it can? Because really what my side, the client side, because we're just being a client to this API, right, to this website, really all we're doing is we're spending most of our time waiting for the server to do the work. I would much rather, knowing that the server can handle multiple requests at the same time, I would much rather in parallel get those back, because it's not me that's waiting, we're doing work, spending my time, it's me just waiting. So if I can parallelize it on the other side, right, then I can actually do this faster. So really what I want to do is I want to eliminate these awaits, because I want to do all of these all at the same time. And so it will start this, it'll start asking for this, and it'll say, all right, I'll wait, and then it'll immediately, after it initiates this, is going to go back to this, and then it's going to keep going all the way through. Now, there's one thing we have to do still in order to do this, is we need to use the promise library. So I'm going to say promise.all. This promise is a built-in keyword. Before I introduce promise.all, let me do this. I'm going to wrap all of these into an array. So what does that mean? My requests. I'm just a variable, and I'm just putting all these requests into an array. Like that. And then I have to run lots of stuff down here. So I am going to just run that. And you'll notice it returns 5 promises, right? But how would I do that? So I would need to do a .then for each one. But I really just want I want to bundle them all up, right? And just take care of them all at the same time. I don't want to do a .then for each one and pass a function to each one, and then, because I need to actually use them all at the same time. So I'm going to have to bundle them together at some point. So why don't I bundle them together to begin with? So the way I can do that here is I can say promise. This is a built-in library to JavaScript. I don't have to import or anything. It's just a keyword. And I can do promise.all, my requests. And I can say let responses equal promise.all. And let's look at what responses gives us. Gives us one big promise. And so let's just do this. Let's await this promise.all. So what we're saying is I'm just going to await all of these promises. So I'm going to bundle them all together with that .all function, and then I'm going to await that they all come back, and then we'll print them out. And there we go. We have all the responses right there. Now that's pretty cool, right? Because that is actually really fast. Unless you used async await in Python, which exists, by the way, but unless you used async await in Python, you would have to wait for each one of these to be executed. So if we do that same thing in Python, so let's do a def lots of stuff. And I'm going to do this. We would have to wait for each one of these to execute. There's no way around that in Python. We're going to block for potentially, if each one of these takes 500 milliseconds, right, we would block for a total of what, 2 seconds total? Whereas this, in theory, if the server can handle parallel requests, you could probably get away with only blocking for the time that it would take for one of these calls, 500 milliseconds. That's a pretty powerful thing if you think about it, right? Imagine if you had to do a ton of these requests, which you end up having to do oftentimes with microservices and managed services and all the different things that we do. That's a really, really amazing thing that asynchronous programming gets you, and that's why JavaScript is very powerful in this respect. So here's the other thing, though. We actually need to chain all of these together, because what this gives us back are a bunch of these response objects. But remember, we have to do an additional step. We have to do that. We have to convert it to that .json. So we have to get the JSON out of it. So what would we do? Well, what we can do here is we can use another functional thing. We can say responses.map each response. We can say a response .json. You can return that, and I'll do a promise.all on that. I think I was going too fast there. We have to await that promise.all. And there's all of our answers. Now what did I just do there? That must have looked like some crazy ass shit right there, right? Like, what was all of this? This .map, and then there was some funky stuff in here. And then you awaited all this promise.all. Oh man, this is getting deep here. So, how can we expand this out a little bit to make it a little more realistic, right? So, if we remembered, each one of these responses is that response object that we have to do a .json with, right? Which is basically that thing right there, right? So let's do it to where we make a for loop. So let I equal 0 for until I is less than length, responses dot length, and then I plus plus. Most of you remember how to do for loops, right? Might have been a while, but for loop, right? So we're just going to keep counting up, and we're going to say, okay, for each one of these responses of I.json, I am going to await that. And I'm going to make a let JSON datas equal to an empty array. And then I'm just going to JSON datas dot push each one of those into that array. And then I should be able to print those out because I'm awaiting basically this response. right? That's a little easier to understand, right? We're just looping through each one of those responses so that then we can call that .json on it, right? So let's see if that actually worked. Yep, that worked. So that was that's a little clearer, right? As to what it is. It's actually the exact same thing as that, but it's not as performant because we're not really taking advantage of the asynchronous nature of what promises and futures give us, right? Because what we're saying here, we have to wait for each one of these .jsons to be evaluated. That's not cool. So is there a better way to do this? Well, the way I introduced first is the better way to do it. Now here's the reason for that. I'm going to comment this out. I'm going to re-comment this back in so I can explain each one of them. So let's just talk about first this thing right here. This responses.map. So what I've done here is I'm using this built-in function. So we know responses is an array, right? Arrays have a built-in function called map. And what a map does is it takes as an argument, it's that function, it takes as an argument another function. So I'll make this a little more clear so we don't do some weird syntax stuff. Make it a little more clear. I've just defined a function, and what that .map does is it takes another function as an argument and then executes that function on each element of the array. And this response is just each element of the array. So it's just going to go through each one of those promises, and it's going to execute on each one of those. Specifically, it's going to just do a .json. So for each one of these in this array, responses in this array, it's going to just turn that into response. The same thing as just doing responses of I. We've just let it kind of syntactically give us a little bit of sugar there. And then .json. But if you notice, we're not awaiting here. And the reason we're not awaiting is because this map function actually allows us to do this in an asynchronous way. So it's not blocking. A map is not blocking like a for loop is. Specifically the for loop that we wrote here to where we're actually making this thing await. So instead what we're doing is we're wrapping this thing in a promise.all because this map returns a function or an array. So why don't I just want to prove this to you guys. So what does this thing right here return? So we'll run this. It returns an array. And it returns an array of promises, specifically promises that are this .json, this conversion, right? This deserialization of these responses. Because if you remember, this response.json returns a promise, right? So we have all of this stuff, and then what we're saying is, okay, so if this is an array of promises, then I should be able to do the same thing I did up here and do this to promise.all, right? On this array of promises. And so I'm going to do that. I'm going to then get rid of this, and I'm going to say promise.all. I'm going to wrap that. And then I'm going to say let x again equals that. So we've got that. We get one promise, because promise.all returns a promise, a bundled promise of those 5, right, promises. And in order to do that, I'm just going to await this. So that now I've basically concurrently said I'm going to evaluate each one of these response.jsons. And I'm going to then get this x and console log it. And I should get my answers. So, a lot of stuff happened there. But let me do this. So I just, instead of saying X, I'm calling it JSON datas. And I'm going to log JSON datas here. Just to prove that I didn't change anything crazy. Okay, so we got that. So these two things are functionally equivalent. This thing and this are the same. Well, not quite, but they get you the same thing. The thing that's not the same about them is that this one does it concurrently, whereas this one blocks on each execution of this conversion from JSON. Because we're awaiting each time we go through this loop, we're awaiting it. Whereas with this map, we're saying, look, just go as fast as you can, return the promises, and then I'll just promise.all it, and then await that one, as opposed to awaiting all of them stacked up. So, yeah.
Question here. So how do you determine that? So you determine that this is going to take a longer time, longer time to process than the previous one. How did you determine there is any method to determine? You know it, you are saying it, but how do we know while practicing a program like this, this one is better than that? So is there any function to test it, or response time? Or...
Yeah, there's a node profiler. Let me look. So it looks like there's a console.time here. Let's try that out. It's been a while since I profiled anything in Node. I usually use a profiler, which is like a whole wrapper for things. I don't want to introduce that here because that's a whole nother thing. But let me... I'd be surprised if we actually see any time difference in this, because this is such a simple example that I don't think it will make a difference, but it might. So let's do console.time here. Time end. Okay, and then we'll do a console.time here. Console.time end there. Can't redeclare the same array. Tell you what, instead of trying it that way, okay, lots of stuff 1, and then we will do lots of stuff 2. Do the exact same thing, except instead of doing our little thing there, we'll do that. So I basically just copied, right, lots of stuff 1 and then lots of stuff 2, and then I just changed our algorithm, right, in there. Oh, wow. It did make a difference. Sweet. I'm not a liar. It made a huge difference. Order of magnitude difference, if you look at it. Like, massive difference. Like, in my world, like 1 millisecond is, like, huge, right? And in your world, too, probably, in many cases. Probably if you do, like, NVH. Yeah, that's 1 millisecond's a long freaking time, right? So in this case, you can tell it took some time to wait to serialize that. Whereas here, we were able to get multiple workers working on it, the event loop. It's not really actual multiple workers. It's not multi-threaded. Definitely not multi-threaded. That's kind of the beauty of it. There's issue. You can get the Python to do the same thing, but you have to multi-thread it, so you have like critical memory sharing issues and everything. We'll go into that later at some other point. But it's better if you can keep everything in the same thread, right? That's kind of the basic rule of thumb. And so here, you basically are just able to shove it on the event loop in JavaScript in Node, and then evaluate them. So this first one, which is where we did it slow, that for loop, where we awaited each time, so we waited each one to be finished. And then here, we actually said, okay, I'm going to take this map, get them all, bundle them all up, and then submit them, and then let them all be worked on at the same time, kind of, operated on, and then just get the same thing. And so I bet here, let's do one even worse, because now I'm interested in this, because I was surprised at how the difference. That was so cool. Here's what we'll do here. So on our bad one, I'm going to await each one of these, right? And I'm going to await each one of them one after another, right? So this first one has to return before it even starts working on this one. Whereas down here, I'm doing them all at the same time, right? Let's see what kind of difference that makes. even worse, right? I even picked up some time, which is interesting. It probably optimized it. Doing timing tests like this is pretty dangerous or misleading in many cases, because there's so much optimization that's happening underneath. So you run it once, V8 Engine's actually optimized and cached a lot of that stuff already. So it's hard to kind of.
Yeah, I see the difference in the timing on the second line, and now it's different from compared to the previous one.
Oh yeah,
right.
In fact, it's almost an entire second more. So it took almost an entire second to return that.
Not only that, you didn't change the second. Means a lot of stuff too. But if you look at the time, it's like 0.6 versus 0.7, right? Is it because of what is it? Why there is a difference that?
Yeah, the reason, because this is the exact same thing we ran, right? That's probably because of caching. I bet the CPU cached. I bet the V8 engine probably cached some of the response. It probably recognized, oh, you're running that again. I'm going to use some of the results from that, particularly the serialization, I bet. Not to mention the function stuff. Invoking a function is a relatively expensive process in an interpreted language, because it's actually having to interpret that, and then put it onto the heap and then execute it. chances are it said, well, nothing changed with this lots of stuff too, so I'm not going to actually go through that interpret step, and it cached that. So that's probably why we picked up a little bit of time here. I bet if it's also possible that's just because of the clock cycles, because I'm running a bunch of other stuff. It's possible I got better timing on the CPU. You know, my computer just happened to preferentially give that. Let's run it again. Let's see what we got. Let's see, it's getting better, right? Yeah. Oh, right here. What happened there, right? Here's the other thing we're doing in these functions that's non-deterministic. We're going out and hitting another server, right? We're hitting this JSON placeholder at typeofcode.com. And it's very possible that the routing that we're using and that IP tables and everything is a little bit slower, or it's not taking the same path, or maybe that server is under heavy load at that point. Well, we know we're loading it. It shouldn't make a difference, right? We're not really doing anything much with it, but it's probably enough to get it to, you know, do that. So it's non-deterministic in that sense. So that's why we're seeing you know, it's not going to be the exact same every time. In fact, if you did it without the dependency on this server that I don't know anything about, you know, sitting somewhere out there, you probably will still get variability because of how your CPU timing is, how your PIDs are set out in your operating system, where you're at in your memory space, all the different things. It's such a complex stack to get that. But generally, I mean, we've run enough experiments here to know observationally you're getting some pretty good performance improvements by doing it this way, right, with maps and with our bundled promises, as opposed to this way, which is wait for it all, right? Wait for each line and line by line to execute. So that's the power. We saw a glimpse of the power of JavaScript.
Python has a similar clocking tool.
It does. Let's see here. Python timing profile. There is a C profile, which I use a lot. I'm looking more for like a TikTok, like in MATLAB. You guys use TikTok in MATLAB at any point? Do you remember that? Yeah, I mean, C. There it is. Yeah, so they just want you to do time like that. So let's do that. This is interesting. Since we have our equivalent Python, right? How much time did it take Python to do it in? Not a fair comparison at all whatsoever, guys, but we'll do this anyways. Import from time, import time. That might look weird because the package is called, the module is called time, and it has a function in it called time. So yeah, otherwise it's time.time, right? So so let's do this. Lots of stuff, and we still have to do this res.json. So I've got my responses, my requests, I'm just making this look like my JavaScript code as much as I can here. I don't know why that's not, whatever. All right, so that's my requests, and then what did we do here? Responses. That's kind of an unnecessary step, right? But we don't really have an async await, thing in Python. Well, we do actually, and I use it all the time. But let's not do async await in Python. It actually looks identical. It's literally async await. But let's just do JSON datas, and I won't do list comprehension or anything. I'll show you some cool Python syntax things, but so I'll do a for I in JSON datas. That's a for loop in Python. So a lot more Pythonic. What would say Pythonic? It's easier to read, right? So it's for each element I in responses. So for each response in response, I'm going to JSON datas dot append instead of push. So just put it on there. Response dot JSON, and then print JSON datas. So that this is equivalent to lots of stuff 1 over here. All right, right. So we got that done, Python. Okay, so let's do our timing. So we have to do time. We'll just do a tick-tock here. Right, so I've assigned tick to this first time, right? And then I'm just taking the time now, right? And I'm just subtracting tick from it, and that's going to give me my talk. So that's going to be my elapsed time, right? So print my talk, elapsed time. That's not bad. Not bad at all. If we remember right, we're pretty much doing it around the same time as our really quick, our asynchronous node stuff. Now, why would that be? Oh. I think I know why. I have Python turned on. So it's actually doing compilation step, as it turns out. So we won't get into the details of it, but this is actually being compiled, whereas in this it's not being compiled. It's being interpreted. So that's probably, if I had to guess, why we're seeing performance like in the asynchronous version of Node. And I would suspect this to be right around the same time every time, except for maybe a time or two when the back end doesn't have it. No, there's a long one. I think where it's getting long is when we start getting rate limited by that server. I think the server starts slowing you down if you make too many requests.
And here you didn't have to install a time package before.
No, that's built into Python.
Oh, okay.
Yeah. Yeah, time is built in.
Same way the dev tools as well.
DevTools I had to install. Pip installed
Oh,
Dev.
okay. You did.
Yeah, I did that. Yeah, I did that a while back. Right there.
Yeah, yeah.
Yep. That's kind of a cool exercise. I haven't done that in a while, so that was kind of fun. Especially this over here. I am really happy that did not make me a liar. So any other questions? It's going to take some time to get really familiar with this. This is all experience, guys. Like, this is it. I can't tell you how long it took me to really get comfortable with that. It took me a really long time. I came from MATLAB. That's what I was doing in graduate school. Fortran, even I did a whole distributed processing named Fortran for thesis and everything. So I mean, it took a long time, but now I actually prefer it. In Python, I actually will use map. So in Python, instead of doing this, I mentioned I was going to kind of show you there's things called list comprehensions, which are vectorized in Python. And so instead of doing this for and loop kind of thing here, what we could have done is we could say JSON data is equal to for a response in responses. Well, you can basically just do why am I blanking on this? Oh, that's why. Basically what we're saying is return response.json for response in responses. And what that does is it actually returns this. So this is equivalent to those 3 lines of code, to these 3 lines of code. It's actually faster. In theory, this would not be any faster, but if you have very large lists, they end up being faster. So a little bit of syntax here. The other thing you can also do is a map where we can do JSON data is equal to map of a lambda function response, and we will do a response.json, and we want to pass responses in there. That is also equivalent, but it's the same. It's actually the same as this map right here. It's a very functional type, what we call a functional thing, a map reduce, very functional thing. What we're saying here is we're taking an anonymous function, or what Python calls a lambda function. So it's an unnamed function. Same thing we're doing here. This is also an anonymous function. Right? We don't name the function. We're just saying for a function we do that. This lambda then is just a function. We're saying it has one parameter called response. Same thing here. And we're just returning response.json. And we're doing it over this variable responses. And we're returning JSON datas. And actually, this returns a generator. It's a type in Python. Generators have like iteration components, and so you have to actually convert it to a list or an array in Python that way. So all of these 3 things, I'll call this traditional. This is Pythonic, so this is the way if a real hardcore Python person was like, say, this is how they would tell you to do it, and then this is how a functional person would tell you to do it. A functional programming person. We're all functional, I think. Unless you code in JavaScript, then you're just ridiculous. But then this is the functional way to do it. So those are 3 equivalent ways to do something. I tend to do this because I come from JavaScript and I do a lot of JavaScript stuff. So I'm naturally going to do this. I find this harder to read, but much easier to code. This is really easy to read if you think about it, going through quickly if you get used to it. This is a little dirtier, but very good for beginner, right? Because it's very clear, like we know exactly what's going on there. So who knows? I don't really care which one you use, but there's a number of different ways to do that. Cool. Any questions? Cool. You guys are experts now.
So maybe a dumb question. So what is the use of a lot of stuff 1 and 2? Do we need to introduce it, or even without that it work?
What do you mean?
A
Like,
lot of stuff 1 and 2.
oh,
So
the functions.
yeah.
And what was the question? Sorry.
Means what is the use of the means you want to define the whole thing as a one function, that's why I introduced.
You're just muted out there.
Oh, okay. I understand. So you call that as a function, right? A lot of stuff. But even prior to that one, you ran the whole program without the lot of stuff function.
Yeah, so here's my two functions I defined, and then I just ran them both, right?
Okay, my bad. Maybe
Okay.
I will look at the video again and ask you later.
Yeah. Yeah, I think, yeah, take a look at it. I think it just really comes down to, I just defined two functions in order to make it a little bit easier to time that way. That's all.
And PJ, this rest.json or same rest.json in Python or JavaScript, .json is a built-in method, right? I mean,
It's built in. It comes back on the object once again. Like we use a lot of object programming, like in how we use our libraries, but we don't necessarily define objects ourselves unless you need to. That would not be my first recommendation. But this return, right? Let me look at Python here. Let's go up to this one, right? This is very simple. So this request.get returns a response object, and that response is actually a request object, a request response object, and it has a method called .json. It also has a method called .text. It also has a number of other methods like status codes and those types of things. So it's a nice way to package that stuff up. But the reason it says .json is because, and why you need to call it as a function, is because there is a deserialization step that occurs. So if you think about it, what's coming in, going back to that network video, right, that I did in prep, all that's coming back from the server is a stream of data, right? I mean, there's no rhyme or reason to it. It's just bits and bytes. So we need to interpret that in some way. Well, there's really you have to leave it up to the person who's the client who's receiving it to interpret it in the way they want it. So they're not going to just automatically deserialize it in this library. This is a general purpose library. So you may expect HTML. Well, if you expect HTML, there's no reason you'd call .json on. In fact, .json would fail because it's not JSON. So that's the reason they give you lots of different options to do that. And oftentimes, in like when I'm writing, libraries and things for myself to use, and I know it's all JSON, I'll actually wrap this function into a get function, and then I'll always just do that .json in it. So I never have to do it multiple times. I'll just say, all right, well, I know I'm going to be using this, so I'll make myself a library. I'll do a def get, and then I'll do like a URL, right? And then what I'll do is I'll just do a res equals request dot get URL, right? And then I'll just do a return res.json. And then I'll just use this get everywhere. So it kind of does this step for me. But you'll see that in a lot of my code everywhere. Like I'll do things to where I use a lower level library, but then I just make things easier for me so I don't have to constantly write multiple lines of code everywhere when we know that it's always going to be one thing. So. Any other questions? Cool. Well, that was kind of fun, at least for me. You guys are probably like, I wish I wouldn't have sat through that BS, but that was kind of cool. So what do you think, JT?
Pretty cool.
JavaScript is a very, very interesting language. There was, what was I? Here's a, I'll show you this thing. It's there's a tweet that I came across today, and I had to take a picture of it. And I'm not the only one that believes JavaScript is like this. It's a very common thing in the industry, but that's why I call it a necessary evil. There's a lot of power, though. I mean, we just saw some of the power, right, of it. It gives you that functional asynchronous aspect, gives you a lot of flexibility in how you code something that you don't necessarily get in another language, especially something like Java or C++. Like, you would never even be able to get something like that. Now, a lot of that discussion comes down to, well, a really diehard C++ or even Java fan's going to say, well, you wouldn't need that crap. Well, because like it's already faster. You're just doing all that crap because you're starting out slow. I say, well, maybe, but I get it done a lot faster than you'll get yours done. So it's kind of like, what's really the difference, right? So, so yeah, that's where we're at. All right, cool. So, if you guys don't have any other questions, then I think I'll call it a night. Unless you guys do have questions, happy to keep answering them. But I think that was a good kind of overview.
Well, this was certainly helpful, BJ. This session.
I'll post this code, and I'll post the video too. I recorded this, so yeah. I'll probably comment this stuff a little bit so that you can kind of see where it is, because I did a lot of commenting in and out of stuff and equivalent things and stuff like that. So I'll take some time and comment this, and then push it to GitLab. Cool. I know Justin was around here somewhere, but let me see. I'll be right back. I'm going to go into this breakout room and see where they're doing stuff. You guys still fighting through this?
Yeah, I'm actually about to set up a dev environment with her because she was able to get the week 1 Docker Compose running, but neither of the two containers are compiling. So we've got some apt-get repository issues right now.
Okay, like what's everyone else is compiled.
No,
worked on my machine, worked on everyone else's. What's the difference here?
My guess it's because it's July 21st and the repositories must have gotten switched on their links or something.
Seriously?
Yeah.
How about yours? Does yours fail?
No, because it's cached.
Did you clear the cache?
No, I mean, I'd have to delete all the images that I have.
Yeah, you would just purge, but it's going to take a while.
Yeah, I mean, I could, but it would have to pull Ubuntu down, like from scratch again as well. Our goal here was to get Shweta running the week 2 material.
Right.
So she's got Python installed on her machine. Week 2 runs the client and it runs embedded in Python. Those could both run in separate processes. The only thing we need to get running is an interactive node server.
Okay.
So I was just going to put together a Docker Compose here that sets up an interactive node server.
Yep. Did you try going back to 18.04? I mean, those things don't change.
You're talking about the for the dev
base image? Yeah, the base image. Like, what's the image? 20.04? I mean, those things don't change. I mean, There's no way those images change.
It's not that they changed. It's these apt-get installs that are failing.
Did you try putting it back to 18.04?
No, I didn't try
Try
that.
putting it back to 18.04. I mean, those apt gets aren't gonna change for 18.04. I could see them changing for 20 because that's the latest build, but not 18.04.
All right. Do you want to, Shweta, do you want to give that a shot? The Sumo one, I think, is on 1804. No, it's on Bionic. Which
Yeah,
might be-
and those don't change that often.
Okay.
Those aptitude registries do not change for those things. Yeah, just go back to 18.0 or Bionic. Just change that 20.04 to Bionic or 18.04.
Yeah, let's give
Yeah.
that a shot. I had to remove the libSSL.
That's fine. Yeah, SSL is always a pain. Although I'd be surprised. Well, you're going to need SSL for requests, but so you missed a riveting discussion in the last one. I went through. I actually did node timing on asynchronous calls and everything.
Oh, you show them set timeout and stuff?
Not set timeout. I actually did like console.time and I like hit stuff and compared like for loops versus maps and async and promise.all versus async await. It was really cool.
Okay, yeah, basically showing like what's the difference in terms of performance when you're trying to send off a bunch of requests in parallel.
Right.
That's cool.
Concurrently, not parallel. But yeah, functionally parallel.
Close enough to parallel, right?
Yeah, that's close enough.
Whatever it actually takes, like whatever time it takes to actually send that thing up on the event loop, which is infinitesimally small. Well, not infinitesimally small, very small compared to a real request, right?
Right. Exactly.
This might take a while because she has to pull down the 1804 image now.
Didn't she already pull it down for Sumo?
Bionic 1804.
Technically, although it's probably not the same tag. You might want to try Bionic so you don't have to pull that down since you already have Bionic pulled down. It's all right. Let me go back to the other room so that I can tell them that they don't need to hang out if they don't want to.
All right.
You guys can also just go back to the main room because we're not doing anything back there. And then they can watch this too. That might actually be if they wanted to.
Yeah.
I'm gonna close all the rooms and then you can reshare Shweta.
Mm-hmm.
All right, so they're dealing with Docker issues, but you guys can watch if you want. Still polling, huh?
Yeah.
It might take a bit.
How's your internet connection? Pretty good.
Yeah. Spectrum claims it to be 100 Mbps, but I think 20 Mbps should be good.
What is the Linux image actually? What is it? Maybe 500 megabytes?
Maybe. It's not huge.
Maybe even 300 megabytes. Something
Ubuntu
like that.
server, I thought I just did an install today and it was like 3.2 gig.
No.
The image was. So
Yeah, I don't know
how much of the kernel you're pulling, but yeah, I just did a 2004 server install and it was 3.2 gig.
Yeah, Shweta, you may want to change that to Bionic since you already pulled that down with Sumo.
You want me to stop?
Yeah,
this?
if you click
Yeah.
the green button in the lower left hand corner,
Mhm.
you can close that connection. And then what you'll do is you'll take the 18.04 tag.
And change it to Bionic.
Yeah, just write Bionic.
Where's my repository?
You can type open folder. I think it must have opened in a different directory.
We did it in this one, right?
Yep, that right there.
Ah.
Sorry, you can go back up one level, one more. Now just click that folder and then click open. Sorry, you're gonna wanna, I don't know if this is gonna work.
No, you need to open that folder.
You have to open that folder directly.
Wait.
Go up to File.
Yeah.
And then Open. Right?
So directly this one?
So go ahead and double click that folder there. And then just select that and then say select folder. All right, don't save. Okay, so now you can replace that with Bionic. There we go. This should be much faster.
No.
Yeah, it's having issues with the aptitude repositories.
Are you on a VPN, Shweta? It's almost like it's, yeah. I wonder if there's something funky going on with how you're proxied or something, because this is just so weird.
But I'm not connected on to my VPN yet. I mean, I haven't logged in.
Yeah. And that's just a work VPN.
I think I faced same issue, and I had to go and change a setting in Docker.
Oh, really?
Yeah, I think I briefly mentioned last time I had to give access path in my Docker. So if you want, we can give a try. If you can, Shweta, if you can open your Docker dashboard below.
Where are my folders?
Your Docker.
Yeah, it's going to be on your computer, Shweta. Search for Docker dashboard.
Open the dashboard.
Sorry, I couldn't hear you.
Go down to that type here to search and just type in Docker dashboard.
Okay.
Or Docker desktop or something.
Mm-hmm.
Yeah, Docker desktop. There it is.
I did click right. Is it gonna take a while to open up?
It shouldn't, but I mean maybe.
Does it open as a system down in the corner, down in the right corner?
Let me just see even if it is just trying to open up or not.
Yeah, go down to the right corner, Shweta. See if it's opening as one of the... There it is. Can you right click on that? And can you... Yeah, click on dashboard. There we go. All right, so go up to that settings up there. And what did you do, Sonnet? Go to resources there. Go to file share.
File share.
So now do I add the folder in which we were trying to...
I think in your case, at least you have path up to week 1 bootcamp. In my case, I didn't had even any path there. So I added path all the way up to the development container, and I think that is what worked for me. You can
Okay, so add click the add button.
Yeah.
And then go to wherever that your dev container, your development folder is.
Yeah, this is the one.
Okay.
Yeah, that should be. Yeah.
And then add that one. Yeah. Let's try that.
Yeah.
Okay. So now do you think I should open?
Run the container again. Yeah. Open here.
You probably have to wait for Docker to restart. Might take a bit for it to restart. Justin, JC, we had these problems with one of your development environments, right?
Yeah, on another project.
What did we end up doing? I think we just put it back to. Did you try to do it with fix missing?
The apt install does have fix missing in there.
Okay. Yeah, I've. But no one else ran into this, right?
I struggled actually with this. So, I worked with Justin for a while. I upgraded the RAM. Then at least I was able to go up to certain stage, and then I realized one of the code that it was popping up. Turns out I googled it, and it asked me to set the path basically in Docker, and I did that, and it worked. So this was the very thing that was happening in my case also.
Oh, like this exact like error.
Yeah, yeah.
Oh, go back to your Docker dashboard, Shweta. Go to General. And oh, go to Cancel there. Oh, I guess go to Settings again. I'm looking for where it does the resources. Go back to Resources, I guess. Okay. Can you up the memory to like, yeah, something like that, and then
Is this good?
do a little bit more. Yeah, 8's fine, and then CPUs do like 4. Yeah. All right. Apply and restart. Let's see if it even allows that. I wonder if it's just not enough memory, and it's red herring, JC.
That's what I'm worried about.
How much memory does this computer have, Shweta?
The RAM is 16 GB and I think the hard disk is 250 GB.
Okay, so you're giving about half of it to Docker. That should be fine. The issue is with Windows. Windows is such a memory hog compared to other systems, Mac and Linux, that Sonat was, you dealt with this, right? It's like, 4 GB seems like a lot you're giving it, but it turns out it's not, unfortunately, because, well, it's just the nature of Windows.
So shall I say retry?
Do a open folder locally, and then do that Command or Control Shift P again, and or reopen in container.
And you want the
Down there at the bottom right, or that. Yeah, that's fine. Let's see if giving it more memory allows it to do that. It's possible that the restriction on memory is causing the build to stop at that point, but the error message thinks that it's a problem with APT, with aptitude, but it's really not. It's a problem with the memory. It's just not reporting that it's running out of memory appropriately.
Right. Well, one of the weird things as well is we ran into APT and APT get issues at different locations depending upon how it was caching and what updates were made.
I just posted something in the Slack channel that it's an older issue, but it's similar type thing.
I like number 2 here. Let's try number 2.
okay, do you always
No, go down to the answer there, the accepted answer. It's number 2 in the rewrite the Docker file. So instead of doing apt update, because it's caching, we want to put those all on the same run line, so it forces it to do both. We don't have much control over that no cache, unfortunately. with how this is being built. So do an apt get update ampersand ampersand. So move the apt get update down on the same line with on line 8. So you're going to do apt update
Okay.
ampersand ampersand and then that line right there. I'm sorry, apt get update space update and then a comment out line 7.
Upsi.
And then save that and then control S and then let's see if we can get.
There's an A missing here.
Oh yeah, make sure you put an A there. Let's see if it'll force that no cache build there. So do a don't reopen open folder in container.
Sorry, open.
So go back down to that green. And then the second one, not that first one.
Okay.
Yep. And then just press open. I want to make sure that we'll see if that forces that cache. Otherwise, we're gonna. JC, did you get her to clear and purge her cache or anything? Because we could get her to purge everything and then get her to repull stuff.
Yeah, we'd have to delete all the images too. Well, we didn't do that yet.
That would be.
If we want to, one thought I had was to just build it on my machine and then push the image up to the registry and then have a branch where it just pulls the built image straight down so we don't run into build issues.
No, that's not gonna work.
That there's not going to be an issue having it built on the Mac, right?
Well, it won't work on Windows. It's the same. I mean, it's the same problem that you would have with like why you have to build on the Samba 5 to build an ARM on a Samba 5.
Well, I mean, it could be worth a shot. I do have a. If we want to get.
You can try it, but I don't think it'll work. Different architecture.
With running right now on week 2 material, I do have a branch that I just put up on for the development environment. I'll Slack you a checkout just so that we can get you running inside of Node at least, because you said you have Python, right?
Yeah.
Okay. Can you run this inside of your VS Code?
Git fetch all. Git fetch all.
Yep. And then
while this is compiling, I can.
No. You have to do that inside of Git Bash. Yeah. So do cd ... All right, and run git fetch all.
I think this doesn't work here. I just look at the command.
All right, now paste the next one.
You're gonna have to put a V at the end of that. So press up. Type V.
All right. Put this in your. Do this first.
If she stashes now, I don't know what that's going to do to the build. Because she's basically going to stash that Docker file that we just modified.
Yeah, she can't even switch because it's trying to build. How's the build doing right now? We'll have to wait on the build. Unless we want to abort it.
I would wait on that build.
Seems like this has gone longer than the others, hasn't it?
Yeah, it has, without a doubt. And we haven't changed anything other than that. I mean, I bet it's building. I don't think it's polling. So I think that cache thing is a potential thing, because I think you were running out of resources because you were getting different build, errors at different spots, kind of non-deterministically. And then once we upped the resources, you were still using an old image that was probably corrupted. And so with that APT, with that aptitude registry, so by forcing that update, we're going to force that thing to re-update, and hopefully this will... Spoke too soon. Same thing. I don't know. I mean, honestly, like, I don't know, JC.
Well, we can punt this as long as she can run the dev environment that I just put up there. So
yeah, let's do that. So Shweta, do that git stash. So you can just open locally and then run that terminal.
Okay.
Do a git stash and then do that.
Because this dev environment will be good enough for this week as well, because we just need Node.
Yeah.
And Shweta, you've got Python locally installed, right? So we can run Python outside of Docker.
Okay.
So now I'll go ahead and paste in that checkout. All right, open up VS Code. Okay, go ahead and close your tabs there.
These.
Yep, now go ahead and do the same thing and open this in a container.
You want me to open the folder?
No,
No?
can't go and cancel. Just say reopen in container. This is you're already in the new dev environment.
So what is this, Justin? You just pulled down the node and then you're just doing it in Bash.
Yeah, she's just running inside a node container, that's all, with a couple global installs. So that's done. And that's on the dev environment, so she can run. I've got the projects folder set up there, so we can clone the projects down into it. That's got week 2 on it already.
All right, cool. So you're there.
Okay.
Yeah. So you can do like basically do CD projects, week 2 cloud.
CD and then what?
Then you're going to go into projects. Week 2 without the space.
Oh, okay. Okay.
All right, and then / cloud. All right, so now you're in that cloud folder, and you can run npm install.
That's it?
Yep. Yeah, so this will install the server from week 2. Right, and then you can see the other 2 folders. There's the embedded one, right? So there's the vehicle that we built, and then there's also the main.py for the client, right? So here you can already type nodemon. I don't know if nodemon got installed in that or not. Just type node and then index.js.
Did you expose the ports, Justin?
I didn't expose 9500. I exposed 9000. Here, let me update this real quick.
So Shweta, just do a git pull. Go back to your git bash and just do a git pull, and Justin will have pushed that pretty quickly. Yeah, just run that. He hasn't pushed it yet.
All right, pull now.
All right, now go back to VS Code. You'll notice it's now 9500.
Yeah.
You have to leave the container or leave the dev container and go back in.
Yeah. So do go down to your green button there at the bottom left, and then do a close. No, do a close remote connection, and then just reopen it, and it'll rerun that Docker file. Yeah, that open folder is fine. And find that one right there.
Did we locate where the what the sumo home needs to be for Windows?
If they installed it right, then it should be just on the path. They don't need any of that stuff.
Oh, nice. Okay, so it's already gotten, like, the installation actually puts a sumo home environment variable in.
Yeah, and Tracy should on the path. Let's go into your cloud folder, Swetha, and run the cloud again
Okay.
on the command line.
So shall I just run the index?
You have to go into the cloud folder first.
Yeah, you have to go drill down into it.
CD space projects /week2/cloud.
And then the week 2 needs a hyphen before the 2.
Yeah.
Yep, and now it's just node index.
And then you should be able to open up a browser and hit localhost 9500. Open up a new tab, and then localhost 9500. /health check.
Yeah, I think there's a health check in there.
Health -check. There it is.
Yep.
Running.
Finally.
That's really frustrating.
Shweta, you've got Git Bash open, right?
Yeah.
You want to do a CD into projects?
The small p, right?
Yep.
You can do a tab, Shweta. You can press tab and it'll auto-complete that, so you don't want to type it out every time.
Yeah.
Now go into week 2. All right, and now go into should be a folder called embedded.
Mm-hmm.
Yep, cd into that. Okay, now go ahead and create your virtual environment. It's a virtual env, VIRT. Yep, virtual env, and then space VENV. You may not have virtual env
virtual
installed.
env install, right?
Well, let's see if you have virtual env on your machine already. Yeah, sweet. Okay, already have it. So now, what is it on Windows? Can she use source inside of Git Bash?
No. Maybe she could use source. Yeah, 3.8. Yeah, try source. Try source space VENV. No, this isn't gonna work. She knew she would use the bat file. So go into so Shweta, get rid of source there and type VENV type VENV slash no space slash tab and then press tab twice fast and go into scripts. So type scripts. Okay. Slash tab twice. Yes. And then look for activate. Is activate in there? Should be like an activate.bat.
No.
No, okay. So instead of scripts, go into lib.
Shall I cd dot?
Just do VNV slash lib as opposed to scripts. So just erase scripts and then type L, capital L
Okay.
slash.
Oh.
Go, just press up.
Okay.
Slash tab twice. Where is activate?
It's supposed to be in scripts.
That's what I thought. So where is the activate bat file? It's definitely not in there. I don't know.
I mean, the other option is just putting requests right on the global install for the time being.
All right, maybe it's hidden. So Shweta, just do scripts there. So VENV slash scripts. Scripts slash activate.bat. Well, it did something. Can you do a pip install?
Just pip install
Dash R.
dash
Dash R. Dash R. Yeah, just
Okay.
R space and then requirements.txt.
Is this good?
Yep. And do a Python space main or
Main dot
vehicle.
vehicle dot py.
Yeah, I think it's vehicle.py.
Let me check. So where is embedded?
Yeah, it's vehicle.py.
Yeah, vehicle.py.
I'm not convinced we're in that virtual environment, but I don't know how git bash is doing it.
Okay.
Okay, it's running. You pull up your development environment. Let's see if it's hitting the pull up your development environment in Visual Code. You should see a bunch of there you go.
Mm-hmm.
It's hitting your server, so it's working. I don't know if it's in the virtual environment though. That's really strange, but it didn't complain that activate.bat wasn't there. It would have said it couldn't find it. So I just don't think git bash is showing the venv prefix on the terminal, but I think you're actually in it. So it's working.
Yeah, we got you working. And the client main file there is pretty simple. It just hits the it's just gonna hit the back end.
Mm-hmm. Yeah, I mean it's gonna just return the JSON reply.
Yeah. All right.
Mm-hmm.
Well, I'm out of here, guys. I want to get this video rendering. So, anything else?
So what would be the solution for this error?
The Docker error?
Yeah, the apt get.
Well, we kind of fixed your problem. So that dev container.
Mm-hmm.
I mean, so that node thing that you have running, that is your dev container now. It just doesn't have Python in it. So you just run Python outside of the dev container, and you'll be fine.
Okay.
So you're pretty much fixed up. You can pretty much do everything. In fact, yeah, you can do everything we want.
Okay.
For that. Yep.
All right.
JC, I think we should just get everyone up on a server development environment, SSH.
Yeah, just move everything to DigitalOcean. I think that'll clear up a lot of installation issues.
Yeah. A lot of magic in that, but it's worth it probably.
Setup's the fun part. Come on, you know you love it.
No. I want to get to coding. I want to actually get to creating these systems. All right, guys.
Okay.
Sounds good.
All right, thanks. Appreciate it.
See you guys on Thursday.
Yeah.
All right, sounds good.
Hey, guys.
Yeah.